adalah gejala penghamburan berkas sinar atau cahaya oleh partikel-partikel koloid. Hal ini disebabkan karena ukuran molekul koloid yang cukup besar. Efek Tyndall ditemukan oleh John Tyndall, seorang ahli fisika Inggris. Nah, contoh dari efek Tyndall adalah langit pada sore hari.
This video will take you through the process for loading and running DNA samples on an agarose gel. You will be using a mini subcell to perform agarose gel electrophoresis. The subcell has an electrode wire running across the bottom of each end. This provides for an electric current to pass, which separates the DNA fragments in the samples. First, align the gel so that the wells are closest to the negative or black electrode. DNA is negatively charged and will move from the negative electrode through the gel toward the positive or red electrode. Place the agarose gel into the gel chamber. Add electrophoresis running buffer to the reservoirs at each end of the gel chamber, and keep adding buffer until the wells in the gel are covered by at least 2 millimeters of buffer. Place your samples to be loaded in the correct order according to the lanes they are assigned to be run in. Check your lab protocol for this information. To obtain a DNA sample, slowly depress the plunger on your adjustable micropipette to the first or soft stop. Holding the plunger down, insert the tip of the pipette into the microtube with the DNA sample. Place the tip close to the bottom of the sample, then slowly release the plunger button. When loading the samples, keep the pipette tip perpendicular to the row of wells. This will reduce the risk of accidentally puncturing the wells with the tip. Lower the tip of the pipette until it breaks the surface of the buffer and is located just above or just inside the well. Slowly apply pressure to the plunger button and observe as the sample fills the well. Make certain you stop at the first stop on the pipette, pause, then slowly remove the pipette while keeping your thumb down on the plunger. Once all the samples have been loaded, avoid any bumping or movement of the gel chamber. This might result in the samples spilling into adjacent wells. Place the lid on the gel chamber with the terminals correctly positioned to the matching electrodes on the gel chamber, black to black and red to red. Connect the electrodes to the power supply, again making certain the electrodes match the terminals on the power supply, red to red and black to black. Switch the power supply on, then set the correct constant voltage for running the samples. See your lab protocol for this information. If a timer is available on your power supply, set the clock for the proper time for your run. Press the start button to begin the flow of current that will separate the DNA fragments. At this point, you should be able to see bubbles coming from the wires at each end of the gel box. Notice that the positive or red electrode has fewer bubbles than the negative or black electrode. In a few minutes, you should see the samples begin to migrate from the wells into the gel. Notice as your DNA samples run, the dye front moves from the negative electrode towards the positive electrode.
Adsorpsi adalah suatu proses yang terjadi ketika suatu fluida cairan atau gas terikat kepada suatu padatan atau cairan dan akhirnya membentuk suatu lapisan tipis. Salah satu contohnya adalah saat penggunaan deodoran. Koagulasi adalah penggumpalan koloid karena elektrolit yang muatannya berlawanan. Yang pertama ada koagulasi secara mekanik. Koagulasi secara mekanik mengubah koloid dari cair menjadi padat. Dilakukan dengan pemanasan, pendinginan, atau pengadukan cepat. Contohnya adalah dalam proses pembuatan puding. secara kimia. Koagulasi secara kimia dapat dilakukan dengan menambahkan elektrolit. Salah satu contohnya adalah dalam penjernihan air dengan menggunakan tawas. Dialisis adalah proses perpindahan molekul terlarut dari suatu campuran larutan yang terjadi akibat difusi pada membran semi-permeable. Dan salah satu contohnya adalah pada proses pencucian darah. Sekarang kita mau ngebandingin susu yang ada kaseinnya dengan susu yang tidak ada kaseinnya. Pertama, susu Milo dan susu kental manis kita seduh dengan air hangat. Dan setelah itu kita aduk hingga larut. Nah, nanti terlihat susu Milo yang menghasilkan endapan, sedangkan susu kental manis yang tidak menghasilkan endapan.
Brownian motion. The first evidence that matter consists of tiny particles in motion was given by the English botanist Robert Brown. When Robert Brown was studying the pollen grains suspended in a liquid using a microscope, he discovered that pollen grains were dancing to and fro in a random manner. Similar haphazard motion can also be observed when small colloidal particles suspended in a liquid are examined under a powerful microscope. The zigzag motion is due to unequal bombardment between the suspended particles and the molecules of the surrounding medium. This irregular motion of suspended particles is referred to as Brownian motion. We shall now study movements of large and small particles suspended in liquids. Let us first look at an isolated large particle A suspended in a solution. A number of molecules hit particle A from all sides. On an average, the impact mutually cancels out. So, the resultant force on the particle is zero. Now, observe the particle B, which is very small. Particle B is hit by less number of molecules. Moreover, it is not hit equally from all sides. Due to this, there is a resultant force. This resultant force alters the direction of particle B. When particle B moves, the direction of the resultant force also changes, resulting in a zigzag motion. Let us now understand Brownian motion with the help of an experiment. Fill a hollow glass cube with smoke particles. Place it under a low-power microscope. Simultaneously, illuminate the cube with a light source. We observe that the smoke particles appear as bright particles moving in all possible directions, in contrast to the black background. This is an experimental evidence of molecular motion or Brownian motion.